A very important element of functions that we can look at is the domain of functions. So what's a domain of a function? A domain of a function can be defined as a range of inputs. Remember, we said that these were inputs, the x values, for example, in this case, for which the function is actually defined. Okay, so whenever you have to work with the domain, you have to find the domain. The best way that you can think about it is always your calculation it's always easier to find the values for which it is not defined. Then around that, you can actually define everything else that will actually define the function. So for example, if I said I need to find a value for which a function is not defined, and the value I get is 0, it means that everything else other than 0 is going to be what? Is going to be defined for that function. So very important definition. So a function has to have values for which it is actually defined. So now let's look at this example that I've boxed in green. Okay, fx is equal to root x minus 2. So the example we looked at is fx is equal to root x minus 2. So now we have to remember what we discussed. We had discussed and said that we need to understand when we see a radical sign, what values around this can make this whole statement here undefined. It's when we get any value that's less than 0. So now less than 0, meaning that it's negative numbers, because we can't find the square root of a negative number. So now what do? What we do is we come in here, we extract this x minus 2, and then we say that for this to be defined, we need to have a value here that's greater or equal to 0. Now remember, we say we did inequalities, we did how to solve them. So this, we say that if it crosses the inequality sign, because this is not a special case, this does not change the situation here. So we are going to say that if any value is greater or equal to 2, then this is going to be defined. So in official notation, therefore, we're going to say the domain is defined like this, where x is such that, remember we said that this is a statement which says that this is such that, I'd emphasized earlier, this is such that x is greater or equal to 2. And what's the other remaining part? It's that x belongs to the set of real numbers. Okay, once you finish this, then you've made your domain. Now we can even prove here to say that if, for example, I were to get a value which is, let's say I get a value which is less than, which is on the other side, it's less than 2. So for example, I get 0. This f0, okay, will be square root of 0 minus 2. So f0, therefore, gives us root minus 2. So we cannot have a value of this because that's an imaginary number. Now you have to go into i's, you have to go into square roots of 2 and things like that. So this is not going to be true. So you can see that this is actually a correct statement. So these domain issues can actually become very, very complicated sometimes. So you just need to know, like I said, what makes the function undefined. So again, here we're looking at the radical sign. Okay. Now, if you have the radical sign, we say that we don't want anything to be inside here that's less than 1, like at this level so far. So what we do is less than 0, sorry. So what do we do here? We say that x plus 5 and we have to be very careful. We can already say it's greater or equal to 0, because if we put 0 there, 0 functions. So now x will be greater or equal to -5. So it means that everything above this number here works. So if I were to put -6 here, I'll have -1 in here, which is not going to give us a defined function. So this is going to be the domain, and we can put it in its full format if we want, where we say the domain is it's going to be like that, where we say x is such that x is greater or equal to -5. Then we are going to say and then x belongs to the set of real numbers in this case, okay? Because you can even include, it's not just integers or all numbers. A 2.5 would make this valid and things like that. Now, these are very similar functions here, but one is the inverse of the other. Is the range going to be the same? That's the question we must ask ourselves. No, it's not going to be the same. Why? Because here, remember, we said that 0 is okay. But what has changed here? What has changed here? There are two things that must not be found here. So the first thing is that we don't want to have x plus 5, which is this expression inside here, to be less than, we don't want this to be less than 0. So we want it to be greater or equal to 0, right? What's the second requirement that we see here? The second requirement is that now we've got a situation where we've got a number, an expression that's under here. Now we say that also this is undefined, right? We said it's undefined. So we also don't want to have a situation where we get a 0 here. So what does that now mean? Is that we are going to change this. Instead of saying less or equal to 0, that becomes like that. Okay? That becomes like that. So what does this become? It becomes like x plus 5 is greater than 0. Okay, because we don't want a 0 here. Also, we don't want a negative number in there. So that these two conditions. So therefore, x is greater than -5. So if I were to put -4 here, it means that this works. But if I were to say even, if I were to include, let's say, a -5 here, then I'll get a 0 here. A 0 is fine because I can get a square root of 0, which should be a 0. But what does that give me? That gives me this statement. And that is something that we don't want to also arrive at. So you see the change that this creates. So there's that change just by making that inversion.